so section 5.4, adding and subtracting polynomials. Okay, polynomials. So we're going to go over these objectives. Identify terms and coefficients, combine like terms, know the vocabulary for polynomials, evaluate polynomials, add polynomials, subtract polynomial, and then what? With more than one variable from the polynomials. Okay, so first let's review this basic concept that we had already learned. Okay, how do you understand an exponent? See, for example, 2 times x times y to the 5th power. The 5, okay, we say it is exponent of variable y, right? And then how about this x? 1 is exponent of variable x. So exponent is a subscript number after a number or a variable, okay? It's usually on the right shoulder of the variable, okay? You guys, okay? So when we later will talk about what is exponent. From this term, 9 times x cubed times y, what is the exponent of variable x? What is the exponent of x? Of x? 3. Yes. Yeah, sorry, I changed, okay? What is exponent for variable y? 1. Yes, you're right. Okay. Next concept, coefficient. How do you understand coefficient? Number multiplied in front of a variable, okay? Well, see, for example, this term, 2 times x times y to the 5th power. What is the coefficient of this term?
2.
2, yes. The number in front of the variable. This term, -3 times x times y to the 5th. What is the coefficient of this term? -3, okay? Yeah, -3, okay? All right, term. Term is coefficient multiplied to variable with exponents and separated by what? Plus or minus sign. So for this term, if we consider -3 the coefficient, okay, so we're actually adding this term by this term, right? Or if you say this term, we should have a 3 times x times y to the 5th, then we're what? Subtracting this term, 3 times x times y to the 5th, okay? So either by plus or minus sign, okay? And then those are gives us what? Terms. How many terms are in this polynomial? How many terms? 2 terms, right? If a polynomial has 2 terms, we give it name for what? Binomial, okay? Binomial. So later, they are asking you, what is a binomial? When a polynomial has 2 terms, it is called what? Binomial. When a polynomial is called monomial, it only have 1 term, okay? If a polynomial has how many terms? 3 terms, it's called what? Trinomial. If a polynomial has over or more than 3 terms, it's just called what? Polynomials, okay? Polynomials. Okay, so polynomial is a statement with 1 term or many written in descending order of exponents. Okay, yeah, so statement with 1 term or many written in descending order of exponents. Okay, so how do you understand descending order? Okay, that means what? We have to look at the degree first. Okay, how about degree? Degree is highest total exponent of any 1 term in a polynomial. So in 1 term, it is a total exponent of any what? Yeah, total exponent of all of the variables in that 1 term. That gives us a degree for that term, okay? So for example, guys, 2 times x to the 1st power times y to the 5th. What is the degree for this term? Total exponent of any 1 term in the polynomial. So total exponent means we're adding up this exponent from each variables. So the degree for this term is what? 6. What is the degree for this term? 6 again, okay? So this term has degree 6, this term has degree 6 as well, so they are having the same degree, okay? So when we write down this one, we don't have to rewrite this, interchange the position of these two terms, because they're having what? The same degree, okay? And usually we're writing down our answer in descending orders, means the term in front will have a what? Higher degree than the term in the later place, okay? Yeah. Alright, so these are the concepts, so you can review this later, okay? Now I'm asking a volunteer to read this question for us. Example, this question 1, what is the requirement for the question? Anyone volunteer to read? Jose, from you, please.
For each polynomial, first simplify, if possible, write the polynomial in descending order of degree, then give the degree and tell whether the simplified polynomial is nominal. Can I even say that? Whatever in a binomial or trinomial.
You're none of these, right? Okay, very good. Okay, so here, this degree, just now we didn't mention this clearly, so I just want to repeat it, okay? Degree is the highest total exponent of any one term in a polynomial. So when we talk about degree, we talk about what? The degree for the entire polynomial. Okay? What is the degree for the entire polynomial? The highest degree from one term. Okay? Yeah. So highest total exponent from one term in the polynomial. That's going to be what? The degree for the entire polynomial. Okay? Alright, so let's answer the questions. Okay, so are we able to simplify 2 times x y to the 5th minus 3 times x to the 5th? Are we able to simplify? Yes. Why? Because these two terms, they are like terms, right? They have the same variable, x and y. Also, for the exponent of x, they're both 1. For the y variable, exponent is what? 5. So they're like terms, right? And how can we combine these two like terms? 2 minus 3 give us what? Negative 1, right? Then x, y to the 5th. You guys agree with it? Yeah. So if they're like terms, we combine them. If they're not like terms, we keep both terms, okay? So, what is the degree of this polynomial? 6. Is it a monomial or binomial or trinomial? Monomial, because eventually it only have one term, okay? So this is a monomial. Guys, can you try number B? Think about it. 9 times x to the cube times y plus 10 times x squared y to the 4th. Are these two terms like terms? Yes. Yes?
Because they have two different coefficients. Yes.
Yeah, we have two different exponents, right? For this term and this term, they both have variable x and y, same variable. However, in this term, the exponent for x is 3, this exponent is what? 2. They're different. Okay? So when we talk about the like terms, okay, say 3, negative 8, this is a pair of like terms. Why? Because they have the same variable. Also for the exponent, they must have the same exponent as well. So see this one. These two terms like terms? No. So we cannot combine them. No. Okay? So we rewrite the polynomial in the descending order of degree. So what is the degree from this term?
4.
3 plus 1, 4. What is the degree from this term? 6. So this term has a highest degree, right? Higher degree. So we're going to rewrite it as 10x squared y to the 4th at the first. Because it says write the polynomial in descending order, right? And then plus 1. 9 times x cubed times y. What is the degree for the entire polynomial?
9.
Highest exponent. This term has degree 6. This term has degree 4. Which one has higher degree? This one. What is the degree of it? 6. So the entire polynomial, we only count the highest degree from a term, which is 6. Is this polynomial monomial, binomial, trinomial? What do you think? binomial. Alright, now let's look at question C. We have 1, 2, 3, 4 terms. Are they like terms, or any two of them or three of them are like terms? Constant, right to the square, right to the first power, right to the cube. Do you have any like term? No. Okay, we're not combining them. So which term has the highest degree? Right to the cube. Okay, constant will have degree 0. Okay, so y to the cube plus y squared minus y plus 5. This is in a descending order. What is the degree for the polynomial? 3, yes. And then what kind of polynomial it is? Over 3 terms, right? So 4 terms. So it's going to be what? A regular polynomial. You guys agree with me?
If the y doesn't have an exponent, isn't it supposed to be 1?
Yes. If a variable has no exponent on top of it, okay, we always assume it is 1. Okay, the degree is 1. See here, this is x, right? This is x to the first power. This is minus y, right? So we assume this is minus y to the first power. If there's no exponent, the exponent is 1.
Okay, no, I was thinking the highest would have been 6, but I realized that those two aren't together.
No, they're not multiplication. They're just addition, subtraction. So each term is an individual term. Question B. Are we able to simplify this expression? 12x to the 5th. Yes, why? Because we have like terms, right? This is these two, right? So it can be written by 12 times x to the 5th. How can we combine these two like terms? Negative 3 plus 5 will give us what? Positive 2x squared, and then plus what? 2. Right? We copy the 12x to the 5th. Combine these two, give us positive 2x squared plus 2. What is the degree of this polynomial?
5.
Yes. And then it is going to be what? Trinomial, right? Is it trinomial? Yes, right? Okay, so this practice question, we practice about how to find the degree for the polynomial, write down the answer, in a descending order of degree, and then determine whether the polynomial is monomial, binomial, or trinomial, or a regular polynomial, right? Alright, the next question is to find the value of each polynomial for x equals negative 2. Evaluation problem. Okay, evaluation problem. So, okay, let's try the question C and D. Okay. If the function is 3 times x to the 4th power minus 5 times x to the cube plus 2x for x equals negative 2, what should we do? How to find the value of this polynomial? What do we do? Replace this x by what? Replace every x in this polynomial by negative 2, right? So 3 times by negative 2 to the 4th power minus 5 times by negative 2 to the cube plus 2 times by what? Negative 2, right? Now let's simplify. When we have multiplication and exponent, which operation should we do first? We do exponent before multiplication, right? So we have to compute negative 2 to the 4th power. So how do you understand negative 2 to the 4th power? Remember the exponent we learned already? Multiply by negative 2 4 times, right? So 3 times by, can you please tell me what is negative 2 to the 4th power? These two terms together give us positive 4, right? These two terms together give us positive 4. Eventually it's what? Positive 16, right? And then minus 5 times by, let's compute negative 2 to the cube. So, negative 8, yes. And then, what is 2 times by negative 2? Negative 4, right? And then we do it from the left to the right, okay? If we have multiplication, do multiplication, okay? What is 3 times 16?
96.
Try again, please. 3 times 16. Use a calculator.
Oh, 48.
48, yes. And then minus 5 times by negative 8. So negative 5 times negative 8. Positive 4, 40 minus 4. So only have addition, subtraction, do it from the left to the right. What do you get?
84.
Yes. Very good. Can you try to do question D, please? Evaluate this polynomial for x equals negative 2. Just mimic what we have done here. Can you please try to evaluate this polynomial? I will give you a couple minutes. Number D. What's your answer?
Negative 19.
Does it ever get negative 19?
I got negative 11.
Negative 11? Any different opinion? Let's see, okay? So first we're going to replace every x by negative 2, right? Then negative 2 to the cube gives us negative 8. What is negative 2 square? Positive 4, right? Positive 4 times 2, positive 8, right? And then 5 times negative 2, negative 10, minus 9, right? And then we do it from left to the right, okay, because it's only addition, subtraction, so negative 8 plus 8 is 0. Negative 10 minus 9 gives us what? Negative 19, yes. Negative 19, do you know where you, yeah, okay, you got it, right?
Yeah.
Okay. Alright, so this type of question is about evaluation question, okay? Now let's go to the next page, okay? Okay, we're going to know how to add and subtract polynomials, okay? So, for adding, okay, let's do some problem, okay? So let's try the question C. 3C. Add these two polynomials. This is a polynomial. this is a polynomial, right? Because we use parentheses for each polynomial. When we're going to add up the polynomial, we have to get rid of the parentheses, right? So for the first parentheses, if we get rid of the parentheses, do we have to change sign for each of the term inside the parentheses? Do we have to change sign? No, because we don't have a negative sign in front, right? So what we can do is get rid of the parentheses first. We still copy every term from the parentheses. And this parentheses, okay, polynomial. To get rid of the parentheses, what should we do? Get rid of parentheses. Every term remains the same, right? So that gives us negative 1/3 x squared plus 2 minus x plus 3, right? So it's good. And then, do we have any like terms? Like term? Yes. Okay, so what are the like terms?
3/4 x to the second.
Yeah, so this two is a pair. Okay, so what I'm going to do is I use 3/4 minus what? 1/3. That's a coefficient for x squared. Can we? Yes, right? Do you have other like terms? Negative 1/3 x and positive 2/9x, right? Are these two terms like terms? Yes, because both of the term has what? Variable x, okay? So I'm going to add negative 1/3 by positive 2/9 times x, right? Yeah, this is minus 1/3 x. I say this is plus of negative 1/3 plus 2/9. Okay, and also we have two like terms. Okay, so we have plus negative 12 plus 3. Well, you can just copy minus 12 plus 3, right? Negative 12 plus 3, either way, right? All right. So what is 3/4 minus 1/3? How can we combine these two fractions? 3/4, 1/3, do they have the same denominator? No, right? So what is the least common denominator? 12, right? 12. I'm going to write it here, okay? 3/4 minus 1/3. In order to get a least common factor denominator 12, we need to multiply 3 to the denominator from this fraction. We have to multiply 3 to the numerator as well. You agree with that? And then to get a 12 for the denominator, we multiply the denominator by 4, and we do it for the numerator as well. You guys agree with this? Alright, so the first fraction denominator is 12, and the numerator is 3 times 3. What is 3 times 3? 9. And the second denominator, fraction denominator is 12. 1 times 4 is what? 4. So eventually, when we subtract these two, it gives us what? 5/12, right? 5/12, what? Times x squared. You guys agree with me? 3/4 minus 1/3 equals 5/12. Okay, so we have 5/12 times x squared. Now, how can we combine these two fractions? Negative 1/3 plus 2/9. How can we combine these two fractions together? Negative what? 3/9 plus what? 2/9, right? So that gives us negative what? 1/9, right? So we have negative 1/9 times x. And what is negative 12 plus 3?
Negative 9.
Negative 9, yes. Fun. See, when we are adding polynomials by polynomial, when we get rid of parentheses, okay, because it's adding, okay, so when we get rid of parentheses, we keep every term the same sign from the original parentheses, okay? How about subtraction, guys? If we subtract a polynomial, okay, what should we do? Let's look at this question C, subtracting. This polynomial subtract by this polynomial. How do we deal with each term from the first polynomial, parenthesis?
I keep it the same.
Keep everything the same, yes. So 8/5 x squared minus 1/3 x minus 7. And then to get rid of the second parenthesis, because we have a negative sign in front of parenthesis, either after we get rid of the parenthesis, we change sign for each term. Or, guys, this idea looks, like method looks better, okay? We use -1, distribute to each term inside the parenthesis. What do you think? So this is -1 times by 2/3 x squared. That becomes what? -2/3 x squared, right? -1 times by -3/4x give us what? +3/4x, right? -1 times by +5, -5. This is a key for this question because when we get rid of parentheses, and especially when, before the parentheses it is a negative sign, we have to distribute the negative sign, right? Alright, do we have any like terms?
Yes.
Yes, we do. For the x squared term, we have what? We have the 5/8 minus 2/3 x squared. And for the x term, we have -1/3 plus 3/4 times x. And then for the constant, let's do it directly. What is -7 minus 12? Minus 5?
-12.
That's 12. So we only need to simplify the coefficient of x squared and x, right? So how about this? 5/8 minus 2/3. What is the least common denominator? LCD. 24, right? Then 5 has to times by 3, give us 15, minus 2 times 8 give us what? 16. So -1 out of 24. So I'm going to rewrite it here. It equals -1/24 x squared. Did you get this? -1/24? You do? And then this is what? This is, I'm write it here, -1/3 plus 3/4. Okay, so 12. Okay, yeah. So in order to get a 12, from 3 to 12 we have to multiply by 4, right? So multiply 4 to the top, and then this is negative sign, so -4. From 4 to 12 we need to multiply by 3. So times 3 by 3 give us what? 9. So 5 out of 12. Okay, so 5/12 x minus 12. Yes, this is subtraction. What we should do, pay attention, is what? Oh, when we get rid of parentheses, and then before that is a negative sign. Don't forget to distribute the negative sign to each term of the parentheses. See, every term changes sign, okay? +2/3 x squared become minus. -3/4 over x become positive. +5 become -5. And then we keep on adding and then simplifying, right? Alright, question 5. Perform the indicated operation. Okay, so let's try two problems. Okay, let's try question B and C. Okay, let's try question B and C. This polynomial plus this polynomial minus this polynomial. What do we do? Get rid of the parentheses at first. Okay, so 7x cubed plus 4x squared y plus 7xy squared minus 3y to the cube. Before the parentheses, it is a positive sign, or it doesn't say anything is positive. we don't have to worry about change sign. Okay, just get rid of the parentheses directly. Add this parenthesis. Plus 2x to the cube plus 5x squared y plus 8xy squared. Then what should we do? Minus the parentheses. Don't forget to distribute the negative sign, okay, to each term inside the parentheses. So that we should get negative 5x squared y minus 2xy squared minus y to the cube. So no parentheses anymore. What do we do now? Find like terms if possible, right? Do we have x cubed? Like term with any term? X cubed?
Yeah.
Yeah. We have a 7x cubed and 2x cubed. That gives us what? 9x to the cube, right? And then for the x squared y, let's check x squared y. This is x squared y. This is x squared y, right? So we have this term. We have x squared y, x squared y. Positive 5 minus 5, gone, right? So only a 4x squared y is left. Then for the xy term, do you see xy term? We have a 7xy squared, 8xy squared, negative 2xy squared. 7 plus 8, 15 minus 2, right? 13xy squared. And then for the y to the cube, guys, do you see that? I use a triangle for the three terms, right? And then eventually, see, all of these terms already counts, okay, so we don't have to worry about them. There is only a negative 3y to the cube, negative 1 to the y to the cube. So combine these two, they give us negative 4 times 1, y to the cube. So far, so good, everybody? Question, Jose? No? Question C.
Like, can we combine?
Can we combine?
Oh, never mind.
Yeah. See, this is x squared y, this is xy squared. They're not like terms. So we're done here. No more combining, right? Last question C. On the top, we always have the x to the cube, y to the fifth, z. Are these terms like terms? X to the cube, y to the 5. Yes, they're all like terms. So we only need to deal with the coefficient, right? So 3 plus 12 minus 5, right? So 3 plus 12 give us what? 15. 15 minus 5, 10, yeah. So 10, x to the cube, y to the fifth, and d. Let's check the three terms on the bottom. Are they all like terms? Check. X to the 8, y to the 3, z to the 3.
Yeah.
Yes. So we only need to deal with coefficient 7 plus 11 minus 4, right? 7 plus 11, 18. 18 minus 4, 14. X to the 8th, y to the cube, z to the cube. Are we able to simplify this result? 10 out of 14 give us what? 5 over 7, right? You agree with that? X to the cube over x to the 8th. Using the quotient rule, remember we learned before, what quotient rule is telling us what?
To add.
To add or subtract? This is a division, right?
Oh, yes, subtract.
Subtract 3 by 8 give us the -5 times y to the 5 minus 3 is what? 2. Z to the what? What is 1 minus 3? -2. Okay. And if we have negative exponent, we have to rewrite it as positive exponent. By how?
Putting it over 1?
Yes. 1 over this. Okay, well, flip it on the bottom, right? So we should have a 5 times y squared. On the bottom, it gives us what? 7 times x to the 5th times z squared.